Hello, guys. This is my first draft of my presentation for the integer zero. But before we get into this presentation, I want to ask the audience a couple questions about zero. So, what do you think zero is? What is it mainly used for? Why is it so significant in mathematics, and why do we see it so much? And also, the question that everybody is probably asking is, where did it even come from? Well, throughout this presentation, hopefully I will be able to answer all of those questions and any other questions that you might have about the integer zero. But before we get into that, let's first see where zero even popped up at in the first place. So let's dig into the history. So we first see zero pop up in Submarinian civilizations, which were located in Mesopotamia about 4,000 years ago, which is insane to think about because they had a concept of zero so long ago that we barely improved on a couple thousand years ago. But aside from that, they denoted zero by having a space in between numerals to indicate a placeholder. So, for example, they would use, for example, 11 would just be a 1 and a 1 in our numeral system, correct? So it'd be 1 1, which would pretty much mean 11. And then to indicate 101, we would pretty much do 101. But since they didn't have a symbol for 0 yet, they would just leave a space. So it'd be 1 space 1 in our numerals because they didn't have our numerals back then. But aside from that, we also think that Submarinians have passed down their knowledge on mathematics to the Babylonians because the Babylonians had the same concept that the Submarinians had about zero, which was pretty much it being a placeholder and it being denoted by a space, such as how the Submarinian civilizations did it. But the Babylonians fall flaw when using spaces to indicate the placeholder. They found that if we have two spaces, it can in between two numerals, it can easily be misinterpreted for three spaces or for one space, like easily, because there's no way to determine how many spaces there is because it's just an empty gap in between two numbers. So a way that they improved on this is by actually coming up with a symbol to determine what to denote zero, and what they used was actually two small wedges. So with the use of these two wedges, the Babylonians were able to completely get rid of the misinterpretation that was happening between people misreading it because the spaces pretty much weren't as clear as the two small wedges are going to be. Um, Next, we are going to get into another civilization that pretty much also came up with a concept of zero, but this was much later. And the civilization we are talking about is the Mayans, of course. Let me move. Oops. Let me move my little guy. Put it down here for now. Okay. So the Mayans in around 300 AD also created a symbol to represent zero, but as the same as the Sumerians and the Babylonians, they used it as a placeholder rather than for using it in actual arithmetic and etc. But their symbol was completely different than the Babylonian symbol because their symbol represented a turtle shell, but from a side point of view. So instead of looking at a turtle shell from like above, it would be from the side, which I don't know. I think it looks pretty neat. Um, so now we're gonna get into the Hindu Arabics, which pretty much started around the 7th century, and these are the people that pretty much created numerical system that pretty much almost everywhere they use now. So the the numbers that we know are 0, 1, 2, 3, all the way to 10, and then so on. This came from the Hindu Arabics, which is actually insane to think about. But anyway, they were the ones to expand on the idea and concepts of zero. So they were actually the ones that started using zero in arithmetics and in algebra and etc. And they completely changed the world of mathematics. I will expand. I don't have as much information about the Hindu Arabics, but for my second draft, I will make sure to include like a good gist of everything of like the significant impact that their numerical system like has had an effect in mathematics. Okay, so now we are going to get into digits. This one I have not written a lot about, so I'm also going to expand on this topic. So digits. So in our numerical system that we know and love today, our base 10 system, which in my opinion is way easier than the base 60 system that the Babylonians used. Um, but anyway, aside from that, at first they would represent zero by using a dot, and that ended up actually being the symbol that was accepted by everybody for our integer zero. And then I will expand on this by pretty much explaining more about our base 10 system and how zero has a significant impact on on our numerical system. Next, we are going to get into exponents and powers using zero. So let's first ask some questions, because what's the fun in not asking some questions? So, what is anything to the power of zero? Is it zero? We found that anything to the power of zero is actually one. But how did we come to this conclusion? Like, looking at this equation, it doesn't make sense, but we're going to make it make sense right now. Okay, so before we get into how any integer to the power of 0 equals 1, we first need to remember our rules for exponents. So let's take it back to high school algebra, and let's review some rules that we should know about exponents. So our first rule would be the product rule. So x to the power of n times x to the power of n equals x to the power of n plus n, which makes sense. Next is the quotient rule, which is x to the power of m divided by x to the power of n equals x to the m minus n. Oh, that's supposed to be on top. I'm gonna fix that, don't worry. But the x to the this right here. Oh, my mouse doesn't work on here. Well, x to the power of n. Well, it should be equal to x to the power of n minus n. Now, our negative exponents is when we have integer to the power of something that's negative. In this case, we're just going to use -1 because it's the simplest. So any integer to the power of a negative integer pretty much flips it. So we're going to have 1 over x, which is pretty neat. Now that we pretty much reviewed our rules for exponents, we can now pretty much see how any integer to the power of 0 equals 1, which is actually pretty neat. So let's get into that. So using the fact that if you subtract a number, by the same number, we will get 0. So for example, if we have 1 and we subtract it by 1, we're going to get 0. If we have 2 and we subtract it by 2, we're going to get 0. And so on, as long as they're the same numbers that are being subtracted. We're going to use this concept to rewrite x to the 0 as x to the 1 minus 1, because 1 minus 1 is just 0, so this makes the two equivalent. Our next step is going to be using the negative power rule, which I completely messed up on, but I will fix it, don't worry. I'm going to fix it after the video ends. But we're going to use the negative power rule, and we are going to rewrite it. We're going to pretty much rewrite our terms as shown in the rule above. So we're going to write it as x to the 1 times x to the negative 1, which makes sense. We're going to be able to rewrite it as that. And then our next step, we're going to use the quotient rule for exponents, and this is going to allow us to pretty much rewrite our terms again, but now in the form of a fraction. So we're going to have x to the 1 over x to the 1, because x to the negative 1 actually puts the x on from the numerator to the denominator because of that negative exponent. So now we have this. And seeing this, we pretty much know that we can cancel the x's out and then we're just left with 1. So that's pretty much how anything to the power of 0 is 1, because they pretty much cancel out at the end when we start rearranging things using rules for exponents, which I think is pretty neat. So now that we have shown that x to the power of 0 equals 1, let's now see what 0 to the power of 0 equals. So so now, what if I asked you, what is 0 to the power of 0? Naturally, almost everybody would assume it's 0, but after reviewing what we have shown above, it might make you reconsider it being 1. You'll be contemplating. You'll be like, is it 0 or is it 1? Just like the guy in the picture. I like this meme. So yeah, so I've not finished this slide yet, but I'm gonna finish it, and pretty much what the rest of it's gonna be is how x to the power of 0. Many people consider x to the power of 0 to equal 1, and then many other people consider it to be undefined. And that reason being is because there's pretty much no way to confirmly show yet that 0 to the power of 0 equals 1 or 0. So as of now, people just consider it undefined, and that's going to be what my next slide is going to be about. But I haven't made it yet, so not in this video, in the next draft. Okay, so now we're going to get into some elementary algebra. I also have not finished these slides, but I will add more to them about pretty much basic concepts such as whether 0 is even or odd, whether 0 is prime or composite, whether 0 is a real number, a natural number, rational number, irrational. We're pretty much going to determine what 0 is. And then we are also going to explain some basic rules for 0 when coming to arithmetic, such as if you add, pretty much like the additive identity, which is if you add any number to 0, it's just going to be that number, and like other rules such as that. And then we are also going to talk about 0 as a function. I still have not started these slides as well, but pretty much in this slide we're going to be talking about when 0 equals a function like a quadratic, and how we're able to use that to then find the roots to our quadratic, and then to find where they cross the x-axis, because that's what the roots are. So we're pretty much going to dive more into that concept about 0 being a function. So this part should be the most mathiest part of my whole presentation. So yeah, I'm gonna make sure to start working on it. Okay, now lastly we're gonna talk about computer science. So without the number 0, there pretty much wouldn't be any computers or electronics, as a matter of fact, because ones and zeros create this universal language called binary coding, which is actually insane. Because imagine having 2 letters in your language and pretty much using those letters to create an alphabet or to create symbols, numbers, everything just using 2 letters. Like, that's insane to think about. But so I'm not finished these slides as well, but pretty much what I'm gonna dig into is how we pretty much the different ways we can rearrange our ones and zeros to create letters and numbers. So I'm pretty much gonna give a bunch of examples presentation. And then this is going to be my reference slide, but again, I have not finished my slide, so I will make sure to work on it thoroughly throughout these next few weeks. So yeah, thank you guys for watching, and I hope you enjoyed my first draft of my presentation.